In this video, we'll be going over how to use soil moisture data. One of the most common ways for measuring soil moisture is with capacitance probes. These are buried vertically with sensors along their length to measure the soil moisture of the surrounding 3 to 10 centimetres at different depths. The data is usually displayed in two types of graphs, a stacked and a summed, either as millimetres of moisture or as a moisture percentage. A summed soil moisture graph displays the total amount of water in the soil by adding moisture readings from multiple depths over time. Typically, it's shown as a line graph, and it helps track soil water availability, with the x-axis representing time and the y-axis representing total soil moisture. This visualization is useful for understanding irrigation needs, drainage, and crop stress. And they're often overlaid with bar charts to show when rain or irrigation has occurred, so you can see the impacts of rain on soil moisture. To show the data from individual sensors on a probe, you can use an unstacked graph or a stacked graph. The latter is more common and easier to understand. A stacked soil moisture graph visually represents how water is distributed across different soil depths over time. Each soil layer, 10 centimetres, 20 centimetres, right down to the bottom sensor, is shown as a coloured line stacked on top of the others, with the total height reflecting the overall soil moisture. This format allows users to see not just how much water is in the soil, but where it is, helping you identify trends like surface drying, deep infiltration, or water retention in the root zone. On a soil moisture graph, the full, refill, and stress lines represent key thresholds for managing irrigation. The full line, or field capacity, marks the maximum amount of water that the soil can hold after drainage. This line tells you that you're fine and that no irrigation is needed. The refill line is the point where irrigation should start up again to maintain that optimal plant health and keep soil moisture in that readily available zone. Below this, water becomes limiting, and the stress line represents the level at which plants begin to suffer from water deficiency, leading to reduced growth or permanent wilting. And these thresholds are designed to match up with those used to calculate water holding capacity. In the previous video on water holding capacity and infiltration, we learned that these thresholds are linked to soil texture and soil structure. So every soil moisture graph is going to look a bit different. Diurnal stepping is the regular daily fluctuations in moisture, typically showing a decrease during the day due to plant water uptake and a slight recovery or stabilisation at night. This pattern indicates that plants are actively using water, and the depth of diurnal stepping can be interesting too. It could tell you that your root system is developing pretty well, or that moisture levels are low and that roots are headed to the subsoil to get their moisture. Soil saturation can be identified by an increase in moisture, followed by a plateau near the soil's maximum moisture capacity. This indicates that all pore spaces are filled with water. If the graph levels off at these values after rainfall or irrigation, the soil is likely saturated, and prolonged high moisture levels suggest that there's very poor drainage, whilst quick drops imply that there's good drainage and that the saturation period was pretty brief. Water will always take the easiest path available, and in a cracked soil, water moves preferentially downward through those cracks, causing very uneven soil wetting. The image on the right demonstrates water movement using blue dye, and you can see pretty clearly that water has followed those cracks and spread out really unpredictably. This can be seen in soil moisture data when water bypasses the upper sensors and is then recorded on the lower sensors. In its earlier state, you can see that soil moisture moves from the top downward, whereas later on we're getting bars of irrigation, but the moisture is completely bypassing the top 70 centimetres of the soil, but it's lifting moisture significantly at the 80 centimetre mark. To detect soil infiltration issues, you can observe how moisture levels change across the different soil depths after rain or irrigation. Poor infiltration is indicated when layers show little or no increase in moisture, suggesting that there might be compaction, crusting, or hydrophobic conditions, and that you might have to change your strategy for getting water in. On the other hand, a healthy infiltration pattern shows a gradual, timely rise in moisture from surface to deeper sensors. A useful exercise is to compare recent rainfall and irrigation events of a similar amount to see if they have a similar soil moisture pattern. Here we've got the difference between irrigation and rainfall. The latter has clearly infiltrated much better, and it's lifted moisture down to about 30 centimetres. So to recap, soil moisture probes create a moving picture of moisture over time that allows us to track important thresholds like field capacity and wilting point. The lines on our soil moisture graphs are squiggling for a reason, which gives us a heads up on infiltration issues and soil cracking.